You're about to explore the fascinating and mysterious outer solar system, filled with distant planets, icy moons, and hidden secrets. You're exactly where you want to be. Far beyond our familiar home lies a region full of wonders that can redefine what we know about planets and possibly life itself. In this video, you'll discover what incredible storms rage beyond Jupiter, the secrets hidden beneath icy moons like Europa, and why understanding distant comets and asteroids might protect Earth from future impacts. The outer solar system is a vast, mysterious place full of wonders that stretch the imagination. Out beyond the warm glow of our sun, enormous planets, icy worlds, and mysterious moons orbit silently, untouched by humans. Jupiter, the largest planet, could hold over 1,000 Earths within its massive body, and Saturn's magnificent rings shine like glittering jewelry against the dark backdrop of space. Further still, Uranus spins on its side in a unique tilt, while Neptune's vivid blue color stands as a testament to the ice-cold storms raging on its surface. Beyond these giant worlds lies the enigmatic Pluto, now classified as a dwarf planet, yet beloved by millions around Earth. Beyond Pluto, the Kuiper Belt holds countless icy bodies, remnants from our solar system's birth billions of years ago. Even further out is the hypothetical Oort cloud, a mysterious zone filled with icy comets waiting silently to visit our inner solar system. This part of our cosmic neighborhood is so vast that sunlight takes hours to reach these distant realms. Studying the outer solar system gives scientists clues about how planets form, evolve, and what potential might exist for life beyond Earth. Spacecraft such as Voyager 1 and 2 have traveled here, becoming the farthest human-made objects ever sent into space, still sending back messages after decades in flight. Jupiter and Saturn, the colossal gas giants, dominate the outer solar system. Jupiter is a vast world composed mostly of hydrogen and helium, swirling in thick clouds, creating breathtaking patterns and storms. Its famous Great Red Spot is a massive hurricane bigger than Earth, lasting for centuries without rest. Saturn captivates with stunning rings composed of ice and rock particles, glittering brightly and visible even from Earth through a telescope. These planets have no solid surfaces, just dense atmospheres that grow heavier and denser deeper within. Jupiter's gravity is so powerful it helps protect Earth by attracting dangerous asteroids, acting as a shield for our planet. The beauty and mystery of these gas giants fascinate scientists who send missions to explore their secrets. The Cassini spacecraft spent years orbiting Saturn, discovering moons with liquid water hidden beneath ice crusts. Juno currently studies Jupiter, revealing stunning images of storms and complex cloud patterns. Understanding these worlds helps unravel how our solar system formed and evolved, giving insights into planetary systems around distant stars. Uranus and Neptune are called ice giants because beneath their clouds lie vast oceans of water, methane, and ammonia ice. Uranus presents one of the strangest sights in our solar system because it spins tilted almost sideways, rolling like a giant ball through space. Its peculiar tilt means extreme seasons lasting decades, with half the planet plunged into darkness for years. Neptune, further out, glows a bright, deep blue color due to methane-absorbing red light. Neptune hosts fierce storms and the fastest winds in our solar system, racing at over 2,000 kilometers per hour. Voyager 2 remains the only spacecraft to visit these remote planets, capturing stunning images and data as it flew past. These worlds remain largely mysterious due to their great distance, but what we do know intrigues scientists deeply. Studying ice giants helps us understand more about planetary atmospheres, climate systems, and internal structures. They hold clues to the conditions early in the solar system's history, where icy worlds likely formed in abundance. Future missions may reveal more secrets about these distant giants, potentially changing our understanding of planets everywhere. Hidden oceans, towering volcanoes of ice, and thick orange atmospheres are just a few surprises among the moons orbiting the outer planets. Europa, one of Jupiter's moons, holds an entire ocean beneath its icy shell, possibly harboring conditions for life. Enceladus, orbiting Saturn, shoots massive jets of water ice into space, hinting at another ocean beneath. Titan, Saturn's largest moon, features dense orange clouds and lakes of liquid methane and ethane, resembling Earth's early conditions. These moons challenge our imagination with their alien yet oddly familiar environments. Triton, Neptune's largest moon, surprises with geysers spewing nitrogen ice, driven by its extreme cold and geological activity. Scientists eagerly plan missions to explore these worlds closely, hoping to answer if life could exist elsewhere in our solar system. Each discovery from these moons reshapes our understanding of habitability beyond Earth, revealing astonishing landscapes hidden far from our view. Far beyond Neptune orbit, dwarf planets like Pluto, Eris, Haumea, and Makemake. Pluto, once considered our ninth planet, fascinates with its complex geology and thin atmosphere. Its heart-shaped glacier reveals dynamic geological processes still ongoing despite extreme cold. Eris, even more distant, challenges our ideas about the solar system's boundaries due to its size and mass, similar to Pluto's. Haumea rapidly spins, forming an elongated football-like shape, and hosts rings, an uncommon feature among dwarf planets. Makemake, covered in methane ice, displays a reddish hue, indicative of complex organic chemistry on its surface. These dwarf planets act as frozen time capsules, preserving pristine conditions from the early solar system. By studying these distant worlds, astronomers hope to uncover crucial information about planetary formation, migration, and the nature of celestial objects orbiting in the icy depths beyond Neptune. The Kuiper Belt is a vast, donut-shaped region of icy bodies that stretches far beyond Neptune's orbit, extending billions of kilometers into space. This cosmic belt contains countless small frozen worlds left over from the solar system's formation. These icy objects offer a glimpse into conditions from the distant past, preserving the pristine materials and volatile compounds from which the planets formed. Pluto, one of the most famous Kuiper Belt objects, shares this space with thousands of similar icy bodies. Eris, Haumea, and Makemake are other significant dwarf planets located within this region, each uniquely revealing characteristics that help scientists piece together our solar system's early days. The Kuiper Belt's scattered icy objects occasionally drift closer to the Sun, transforming into spectacular comets with long, glowing tails. New Horizons, a spacecraft that visited Pluto in 2015, provided detailed images and data from this remote region, uncovering surprising geological diversity and activity. Further exploration of the Kuiper Belt promises to unveil even more secrets, including insights into the formation and evolution of our solar system and the processes that led to the planets and moons we know today. Each discovery from the Kuiper Belt opens a new chapter in our understanding of the cosmos. Comets are fascinating frozen travelers from the far reaches of our solar system, often described as dirty snowballs due to their icy cores mixed with dust and rocky debris. As they journey closer to the Sun, these icy visitors transform spectacularly, lighting up the sky with brilliant tails stretching millions of kilometers into space. The warmth of the Sun causes the comet's ice to vaporize, releasing gas and dust in a magnificent glowing tail, making comets among the most spectacular celestial phenomena visible from Earth. Some comets, like Halley's Comet, have predictable orbits, returning regularly to delight skywatchers. Others appear unexpectedly, making their visits rare and exciting events. Throughout history, comets have inspired awe, curiosity, and even fear, seen by ancient cultures as signs or omens. Today, astronomers eagerly anticipate each comet's appearance, as these objects carry important clues about the birth and evolution of our solar system. Comets originate from distant areas like the Kuiper Belt and the Oort cloud, preserving ancient material untouched for billions of years. By studying comets, scientists can gain insights into the early solar system's chemistry, including elements and molecules that may have contributed to life's emergence on Earth. Missions like Rosetta, which landed a probe on Comet 67P, have provided valuable data about these icy relics. Planetary rings are among the most visually stunning features of our solar system. Saturn's famous rings, composed of billions of particles ranging from tiny dust grains to massive ice chunks, glow beautifully as they orbit the planet. Despite appearing solid from afar, these rings are incredibly thin, often just tens of meters thick, and spread wide enough to dwarf Earth. Beyond Saturn, rings circle other giants, though much fainter. Jupiter's faint, dusty rings were first discovered by the Voyager missions, and later studied more closely by the Galileo spacecraft. Uranus, with its faint, dark, narrow rings, challenges astronomers' expectations by appearing unusually dark and dense, possibly made from organic compounds darkened by radiation. Neptune's rings are also dark and fragmented, containing clumpy arcs that puzzle scientists. These rings are believed to form from shattered moons, asteroid collisions, or even comet impacts, continually evolving through gravitational interactions. The study of rings provides astronomers insights into the dynamics of planetary systems, including how particles interact gravitationally and electromagnetically, influencing ring structures. Missions like Cassini, which spent over a decade exploring Saturn's rings, revealed intricate patterns and movements influenced by gravitational tugs from moons and the planet itself. The outer solar system hosts some of the wildest weather imaginable. Jupiter's atmosphere showcases the famous Great Red Spot, a storm larger than Earth, raging continuously for centuries. This massive hurricane, fueled by Jupiter's immense internal heat, spins furiously with wind speeds exceeding hundreds of kilometers per hour. Beyond Jupiter, Neptune challenges even this extreme weather with supersonic winds. Neptune's winds are the fastest known in our solar system, reaching speeds exceeding 2,000 kilometers per hour, whipping through its cold, dense atmosphere. These extreme conditions arise from complex internal heat dynamics and temperature differences between atmospheric layers. Saturn, too, displays intense storms, including a massive hexagonal storm system at its north pole, which maintains a bizarre geometric shape driven by unique atmospheric currents. Uranus, despite its quiet appearance, experiences dramatic seasonal weather shifts due to its extreme axial tilt, creating decades-long winters and summers marked by powerful storms emerging suddenly from its serene appearance. Studying these weather systems not only expands our understanding of planetary atmospheres, but also offers insights into fluid dynamics, climate patterns, and extreme meteorological conditions not possible on Earth. Missions like Voyager, Galileo, and Cassini provided unprecedented views and valuable data, helping researchers decode these violent weather phenomena. Powerful magnetic fields around Jupiter and Saturn create astonishing auroras, shimmering brightly at their polar regions. Jupiter's magnetic field is incredibly intense, around 20,000 times stronger than Earth's, stretching millions of kilometers into space. This magnetic environment traps charged particles that spiral along magnetic field lines toward the planet's poles, colliding with atmospheric gases and producing vivid auroras brighter than Earth's northern lights. Saturn's magnetic field, though weaker than Jupiter's, still generates spectacular auroras, glowing in ultraviolet light visible only through specialized telescopes. Uranus and Neptune also have strong magnetic fields, but intriguingly, they are tilted and offset from their planetary rotation axes, creating complex and puzzling magnetic environments. These offset fields lead to uniquely irregular and dynamic auroras and magnetospheres, differing significantly from those around Jupiter and Saturn. Understanding these magnetic mysteries offers valuable information about planetary interiors, especially the dynamo processes generating these powerful fields. Space missions like Juno, orbiting Jupiter, and Cassini, which studied Saturn, have significantly advanced our understanding of planetary magnetospheres, discovering how these fields interact with solar wind and moons. These powerful magnetic fields shield planets from harmful solar and cosmic radiation, making them crucial in shaping planetary atmospheres and potentially influencing conditions suitable for life. Voyager 1 and Voyager 2 are historic, human-made spacecraft, now exploring interstellar space, marking humanity's first journey beyond the planets. Launched in 1977, these twin spacecraft provided unprecedented close-up views of Jupiter, Saturn, Uranus, and Neptune, fundamentally reshaping our understanding of the outer planets. Voyager 1, after visiting Jupiter and Saturn, ventured toward interstellar space, officially leaving the solar system's heliosphere in 2012, becoming humanity's first interstellar envoy. Voyager 2 followed, exploring Uranus and Neptune, and entering interstellar space in 2018. Both spacecraft continue sending data from regions never before explored, measuring cosmic rays, magnetic fields, and interstellar particles, providing groundbreaking insights into the boundary regions separating our solar system from the galaxy. Carrying golden records containing images, sounds, and greetings from Earth, the Voyagers symbolize humanity's curiosity, reaching out into the cosmos. Despite their age, these robust spacecraft continue to operate far beyond their intended lifespans, offering valuable insights about the nature of interstellar space. The longevity of the Voyager missions has provided an extraordinary record of the outer planets and beyond, inspiring future generations of explorers and researchers. Gravity is the invisible force shaping the majestic dance of planets, moons, and icy objects throughout the outer solar system. Every celestial body exerts gravitational pull, determining the paths and orbits of neighboring objects. Jupiter's massive gravity dominates the outer planets, influencing asteroid trajectories and acting as a protective barrier for the inner solar system. Saturn's gravitational influence shapes its stunning rings and shepherd moons, maintaining their delicate balance. Gravity also orchestrates the complex dance of moons around planets, causing tidal heating and geological activity, particularly evident on moons like Jupiter's Io and Saturn's Enceladus. Even distant objects in the Kuiper Belt and Oort cloud follow gravitational influences from giant planets, occasionally sending icy visitors inward toward the Sun. Understanding these gravitational relationships helps astronomers predict planetary motions, satellite behaviors, and potential comet impacts. Missions exploring the outer solar system rely on precise gravitational calculations to navigate spacecraft safely, utilizing planetary flybys for gravity assists, dramatically boosting speed without extra fuel. Studying gravitational interactions reveals deep insights into planetary formation and evolution, helping scientists reconstruct the early dynamics of our solar system. Observing orbital patterns of distant icy bodies and dwarf planets further informs theories about hidden objects like the hypothetical Planet 9 potentially lurking beyond Neptune's orbit. Gravity thus connects all celestial objects, guiding their eternal paths, creating a cosmic harmony that continues to fascinate and inspire humanity's exploration and understanding of the universe. The outer solar system offers crucial clues about how our planetary system formed roughly 4.6 billion years ago. Planets like Jupiter and Saturn, due to their massive sizes and gaseous compositions, likely formed early, quickly gathering vast amounts of gas and dust from the protoplanetary disk surrounding the young Sun. Farther out, Uranus and Neptune captured icy materials, becoming colder, ice-rich worlds. Dwarf planets and Kuiper Belt objects remained frozen in time, preserving ancient conditions from the solar system's birth. Comets and asteroids scattered through these distant regions contain pristine chemical records, helping scientists reconstruct the solar system's early environment. By examining meteorites, comets, and planetary compositions, researchers piece together how dust and gas coalesced into planets, moons, and smaller bodies. The different compositions and orbits of these distant objects also suggest a period of planetary migration, where giant planets shifted positions dramatically, scattering smaller bodies across the solar system. Missions like New Horizons, Cassini, and the Voyagers provided direct evidence supporting these theories. Studying the formation history of the outer solar system not only answers fundamental questions about planetary origins, but also helps astronomers understand planet formation around other stars. Hidden beneath icy crusts of moons orbiting the outer planets lie oceans with the exciting potential for harboring life. Jupiter's Europa and Saturn's Enceladus are particularly compelling, with oceans of liquid water beneath thick ice layers. Europa's ocean, warmed by tidal interactions with Jupiter, contains more water than all of Earth's oceans combined, making it a prime candidate for microbial life. Similarly, Enceladus regularly ejects plumes of water vapor and organic molecules through surface cracks, providing accessible samples for future missions to analyze. Titan, Saturn's largest moon, presents another intriguing scenario. Its methane lakes and thick atmosphere resemble Earth's early conditions, offering a unique laboratory to understand prebiotic chemistry. Missions like NASA's planned Europa Clipper and proposed Enceladus probes aim to directly search for signs of life or conditions suitable for life in these distant oceans. Studying these icy worlds expands our definition of habitability, showing life could exist beyond the traditional habitable zone around stars. Understanding these environments might provide answers to one of humanity's greatest questions. Are we alone in the universe? The discovery of even simple microbial life in these oceans would revolutionize biology, astrobiology, and our understanding of life's resilience and diversity. The outer solar system harbors countless icy bodies, asteroids, and comets that occasionally pose potential risks to Earth. These distant objects, particularly comets from the Oort cloud and Kuiper belt, sometimes drift inward due to gravitational disturbances from nearby stars or planets. When these celestial wanderers approach the inner solar system, they become visible as bright comets, but also potentially dangerous impactors. Earth's history shows numerous asteroid and comet impacts, dramatically shaping biological evolution. The risk of future impacts, although small, prompts astronomers to closely monitor objects from distant regions. Missions such as NASA's OSIRIS-REx, DART, and NEOWISE continually study near-Earth asteroids, developing methods for predicting and potentially mitigating future impacts. Understanding asteroid trajectories, compositions, and behaviors significantly enhances our planetary defense capabilities. Studying distant objects also improves our understanding of their origins, helping predict future movements. Global collaborations, telescopic surveys, and spacecraft observations ensure continued vigilance against potential threats. While catastrophic impacts remain rare, even small impacts can have significant consequences, highlighting the importance of continued monitoring and research. Investigating asteroid impact risks not only safeguards our planet but also enhances our understanding of the dynamic processes influencing the solar system's evolution and stability. Exciting future missions promise deeper exploration of the outer solar system, aiming to uncover new secrets and expand human understanding of distant worlds. NASA's Europa Clipper mission plans detailed exploration of Jupiter's icy moon Europa, seeking potential signs of life within its hidden ocean. Meanwhile, proposed missions aim to visit Saturn's Enceladus, directly sampling water plumes for evidence of habitability. The Dragonfly mission, targeting Saturn's moon Titan, will deploy a drone-like spacecraft to explore its exotic methane lakes and dunes, studying its organic-rich environment. Uranus and Neptune, scarcely visited by spacecraft, may see dedicated orbiters or probes investigating their atmospheres, magnetic fields, moons, and ring systems in unprecedented detail. Advances in technology, including new propulsion systems and miniaturized instruments, make these ambitious missions feasible. Improved telescopes, both ground-based and space-based, will enhance observation of distant dwarf planets, comets, and other icy bodies, offering insights into solar system formation and dynamics. International collaboration among space agencies promises more comprehensive exploration efforts, pooling resources for ambitious, scientifically rich missions. Each future mission expands human understanding of our cosmic neighborhood, answering fundamental questions about planet formation, habitability, and life's potential throughout the universe. Exploring these distant worlds inspires technological innovation, scientific discovery, and human imagination, reaffirming humanity's desire to explore, learn, and venture deeper into the cosmos than ever before. Disclaimer. As an Amazon and other affiliate, I earn from qualifying purchases at no additional cost to you. Do you like the video and want to make videos like this? Turn text into stunning videos in seconds. Get free trial and unlock your creative potential. You can create even better videos than mine. No editor is required. Check out the link in the video description below. Tell us in the comments how you think understanding the outer solar system impacts our daily lives here on Earth. or share any questions you have about these fascinating worlds. And if there's a topic you want us to explore next, let us know. Your idea could shape our next video. Thank you for joining us on this journey through the outer solar system. Please like and share the video, and please do not forget to subscribe for more videos.